All right, so we're now going to go ahead and get started. And we're going to now finish up 1.5. We're now going to be looking at how to solve these inequalities. These have one more step than just an equality. We solve them and then we have to graph them on a number line. One of the most important things that we have to remember in 1.5 is whenever you divide or multiply by a negative, you switch the inequality sign. And usually it's dividing. So when dividing by a negative, flip the inequality sign. Okay, so very, very important. Whenever you divide or multiply, but normally it's divide. So when you divide by a negative number, you're going to have to flip the inequality sign. So we're going to work through several of these. Some of them you'll have to flip the sign. Some of them you won't. Okay, so let's look at some of these here. And let's try to solve and graph on these. And let's say 3x plus 4 is less than a minus 5. So this one's going to be pretty simple to work through. So nothing new. We always want to get our x on the left. So I'm going to move that 4 over with subtraction. And that leaves me then with a 3x is less than negative 9. We'll divide by our 3. Now, we are not going to have to flip our inequality sign. Why not? Did we divide by a negative 3? No. What did we divide by? We divided by a positive 3. So the inequality symbol stays the same. So we now have x is now less than a negative 3. So we'll go ahead and graph this on our number line now. And then write our answer in interval notation. So here's our number line. We find that negative 3 somewhere. And which way is it pointing? Well, it's pointing back to the what? Left. So we shade to the left. And brackets are parentheses. Remember, this is strictly less than. Yep, so it gets parentheses. And where is it going to? Back to the left on negative infinity. So make sure it's in the correct order. We've got negative infinity on the left, comma, negative 3. Okay, do not mix up the order. That's the most commonly made mistake, is students accidentally mix up the order. So this would be your answer now in what's called interval notation. Let's do another one here. Again, solve and graph. About 4 times x minus 7 is, let's say, less than or equal to 8x plus 1. And again, they don't always come out to be whole numbers. You may have a fraction. So let's go ahead and work this one out. Distribute through. That 4. So that 4 is going to get distributed through. And when I distribute through that 4, I get 4x minus 28 is less than or equal to 8x plus 1. I'm going to move the 8x over with subtraction. and I'm going to add the 28. Four minus 8, that makes it a minus 4x. The 28s can cancel here. Inequality symbol stays the same for right now. The 8x's cancel, and 1 and 28 makes it 29. We now need to finish this. When we divide by a negative, when we divide by that negative 4, what's going to happen to our inequality symbol? Okay, we divided by a negative 4. When you divide by a negative, that switches your inequality symbol. And 29 over 4 is not going to reduce down. So that's just going to be left as a minus 29 over 4. Okay, we switched our inequality symbol. Why? Because we divided by a negative. Here's our number line. We've got minus 29 over 4. Which way does it point now? It points to the right, so we're going to shade to the right. Okay, it is x is greater than or equal to, so that means we need a square bracket here. It is going to the right, so that means it goes out to positive infinity. And so what does that now look like in interval notation? Well, it looks like minus 29 over 4 with a square bracket, comma, infinity with parentheses. So there's that one there. We'll do a couple more of these. So let's try a couple more of them, and I'll just pick some from our textbook. So let's look through a couple of these from our textbook. I'll do one that has some fractions in it. How about question number 41 on page 113? And if you don't have your textbook or don't want to get it out, I'll write it up. So it's not a big deal at all. So page 113, question 41. And we've got minus 1/4 times p plus 6 plus 2/3 times 2p minus 5 is less than 10. Okay, so we need to remember fractions again. So this one does have our fractions in it. Always, what do we do first? Well, we always begin by distributing. So we'll distribute through and get rid of our parentheses. Be careful because this is negative, and I like to circle my negatives so that I remember that it's negative. So go ahead and distribute through. And that makes it then minus 1/4 p. Okay, 6 times a negative 1, make your sign correct here, is a negative 6 over 4. We could reduce that down to a negative 2/3, but we're going to clear our fractions anyways. So might as well just leave it as a minus 6/4. Because you could write that as a minus 3/2. What about the next one? 2 times 2 makes it a 4, p over 3. And then what do we have here? 2 times a negative 5. Well, that's a negative 10 over 3. So we just distributed through. Remember, these are always over 1. So all you do is multiply by the numerator. How do we clear our fractions? Well, it looks like our fractions are a 4 and a 3. And the least common denominator of 4 and 3 is going to be 12. So we'll multiply all of this by 12. Did I copy it down wrong?
Yeah, it's 2/3. It's, yeah.
Oh, let's see. Did I copy? Oh, yep, I flipped it over. Sorry about that. My mistake there. I just copied it down wrong. Let me fix it here. That's 3 over 2. Sorry about that. Didn't mean to do that. Okay, so that's the only mistake there. Yep, it's going to be 3 over 2 there. Okay, so now when we distribute, we get 3 times 2, which is going to be the 6. So that'll be a 6 there. Sorry about that. And 3 times a negative 5. 3 times a negative 5 is a negative 15. And instead of having a 3 down below, we've got 2. So least common denominator now of 4 and 2 is going to be what? 4. Yep. And if I make a mistake, if I copy something down wrong, make sure you tell me. But I think everything is fixed now. And sorry about that. I think it's all correct. Now we can go ahead and multiply it all by 4. Remember, these are 2's down below here. So multiply everything by 4 now. That'll clear out all of our fractions. And what do we have? We have 4 divided by 4. That's gone. So that leaves you with a minus p. The 4's cancel, leaving you with a minus 6. 4 divided by 2 is 2. 2 times the 6 makes it 12p. 4 divided by 2 is 2. 2 times a negative 15 makes it a negative 30. And don't forget the other side. 4 times 10 makes it now a 40. I think everything is right now. Sorry about the mistakes there. Let's go ahead and finish this out. So we've got a minus p and a 12p. That makes it 11p. Those can go together. We have a minus 6 and a minus 30. That makes it a minus 36. And what are we going to do next? Well, the next step will be to add that 36 to each side. And then we'll go ahead and add that over. Make sure I didn't make any mistakes. It doesn't look like I did. So we're going to go ahead and add that over. That's going to make that 11p is now less than, adding those together, 76. We're going to divide by my 11. Am I going to switch my inequality symbols? Yes or no? No. Why not? We're dividing by a positive number, so the inequality symbols stay the same. Okay, so we got to this point. We still need to graph it. So here is the 76 over 11. Which way is it pointing? It's pointing to the left, so that's where we shade. We need a set of parentheses here. If it goes back to the left, that's going back to negative infinity. So now in terms of interval notation, it looks like negative infinity to 76 over 11. And both of these get parentheses. Let's try a double inequality, or sometimes the textbook calls it a 3-part inequality. 58. So question 58 is what we're going to look at next here. Let's make sure I write it down correctly. Okay, yep, that all looks right. Just to make sure I didn't copy anything down wrong. Yep, all looks right there. So that's what we're looking at. This is question 58. And again, this is page 114. Now this one's a little bit different. What do we want? Well, we want to get that x by itself in the middle. So if I move that 3 over, with subtraction, I've got to subtract it from all the sides. So it's got to stay trapped in the middle. So that 3 needs to be moved over. So I'm going to subtract 3 from the other two sides. So then that gives you negative 15, a negative 6x in the middle, and 15 minus 3 makes it positive 12 there. Now we're going to go ahead and divide by that negative 6. That gives me an x here in the middle. Now what's going to happen to my inequality symbols? Switch both of them, right? Why am I switching them? Okay, divided by a negative. Negative and negative makes us a positive. And 15 over 6, they both have a 3 in common. So that's going to leave you then with the 5 over 2. So that's the left-hand side. Now what about the right-hand side? 12 divided by 6. Well, 12 divided by that negative 6 leaves you with a what? Negative 2. We have to be very, very careful when we graph this one. When we go to graph it, we need to make sure it's in the correct order. We divided by that negative, which made our inequality symbol switch. Right? So that switched the order on the number line as well. And if we think about a number line, here's our 0. And which number is smaller? Well, the number that's going to be back to the left is our minus 2. The number that's in front is the 5 over 2. I just put the 0 in for reference. So you need to make sure you switch the order around. So negatives are always on the left. Now, what do we want? We want our answer to be in between those two values, and we're going to have square brackets. So what would your final finished answer then look like? In interval notation, your final finished answer is minus 2 with the square bracket, comma, 5 over 2, also with the square bracket. Okay, let's do one more of these, and then we'll look at some applications. Question 64. This is still on page 114 here. So we're going to look now at question 64. So we have a minus 4 is less than or equal to 2 minus 4x over 3 is less than or equal to 0. Make sure everything looks right here. And it does. Now, there are different ways of solving this. We do need to get rid of the fraction somehow. And so the way I think that's going to be the easiest, it might take you a little bit longer, is I want you to rewrite this fraction right here into two separate fractions. So let's take that middle fraction and let's rewrite this as 2 over 3 minus 4x over 3. On the left, we still have a minus 4. And on the right, we have our 0. The reason why I did that is it just makes it easier to see. You could have just multiplied everything by a 3 at the beginning, but a lot of times students make a mistake. And so you're going to be less likely to make a mistake if you split it up. Now we should know what to do. So to finish this from here, well, we can just multiply it all by 3. That's going to now clear out all of our fractions. So I split it up and then multiplied everything by a 3. So now we have a minus 12 on the left. 3's cancel. That leaves you with a 2. 3's cancel. That leaves you with a minus 4x. And 3 times 0 is still 0. Move that 2 over with subtraction from all the sides. Make sure you move it from all the sides to get rid of that 2. Now we've got a negative 14 on the left, a negative 4x in the middle, and a negative 2 on the right. So is everyone okay with what we've been doing so far? Now we need to go ahead and finish this out. And we're going to divide everything by now what? Negative 4. Now what happens again? When I divide by a negative, what is that going to do? Okay, that's going to switch these signs over. And that's also going to switch the order on the number line. So negative and negative makes it a positive 7 over 2 when you reduce. Switch your sign. X is in the middle. Switch your sign. Negative and negative makes it a positive 1/2 when you reduce. 2 over 4 makes it a half. Again, make sure you're careful on the number line. A half is the smaller number, so that's going on the left. 7/2 is larger, so it goes on the right. Our answer is in between, and these both now get square brackets.
When do you use the square brackets again?
Okay, just so we remember, square brackets. If you have strictly less than or strictly greater than, those get parentheses. Greater than or equal to, less than or equal to, whenever they have a bar underneath. Okay, these get square brackets. Negative infinity or positive infinity, it gets what? Parentheses. So because these had the bar underneath, that makes them then have what? Square brackets. Okay, so you got to remember. And infinity, no matter what, gets parentheses. That's a commonly made mistake. The students will make a mistake with the infinity symbol. Infinity always, no matter what, gets parentheses. Remember, this is a half here. It kind of got overwritten there, but that's a half, and that's 7/2. What does it look like now in interval notation for our final answer? Directly off the number line, square bracket 1/2, comma, 7/2, with a square bracket as well. Is everyone okay with that one? Let's look at a couple of applications, and then we'll move on to the next section. The next ones we're going to look at, we're going to have to talk about the average. And how does an average work? We're still in 1/5, but an average is going to equal, depending upon what you're working with now, very easy definition, sum of the scores over number of exams. It could be number of rounds of golf. Okay, this is called your average here. You take your scores, you add them together. Easiest one, I think, to relate to is just your exam. So how do we do those for an average? We add them all up, divide by the number of exams. How do you get average temperature? Well, you would add up all the temperatures for the days, right, and divide them by how many days you've got. So that's the easiest definition of an average. Sum of all the scores, divide by the number of scores or number of exams. I think that makes it easier. Again, it doesn't have to be exams. It can be rounds of golf. It can be a variety of things. So let's look at question 75. So we're going to be having to use the average here. to earn a B in an algebra course requires an average of at least 80 on the 5 tests. A student has scores of 75, 91, 82, and 74. What possible scores on the 5th test would guarantee this student a B in the class? Okay, so let's see what we want first. We want to get a B. And what do we have to get a B? 80 or above. So my average needs to be greater than or equal to 80. So we'll start off with that. Is everyone okay with that? Now, what are we looking at? How many exams do we have? Looks like there's going to be 5 exams, right? 75, we've got 5 different exams here. So we took our first exam and we got a 75. Our second exam, we got a 91. Third exam was 82. Fourth exam was 74. And do we know our 5th exam? No. So that's going to be an X there. That should be plural there, exams. All right, so what's going to be our average? Well, our average, we're going to take these numbers and we're going to add them together. And then how many exams do we have? Well, it looks like we've got 5 total. And that still needs to be bigger than or equal to 80. So greater than or equal to 80. Is everyone okay with that? So let's see how the average works. You add them up, divide by how many you've got. So rounds of golf, you divide by the number of rounds of golf. Temperatures, divide by the number of days. Something like that. So always add them up, divide by your total. So let's go ahead and clean this up a bit. Let's add these numbers up together here. So we've got a 75, we've got a 91, 82, and 74. So that gives us then 320 plus X over 5 is greater than or equal to 80. Let's go ahead and cross multiply. So make this 80 over 1. And we can then cross multiply. So make that 80 and over 1, cross multiply. That gives me 322 plus X is greater than or equal to. We've got 80 times 5, that should be 400. Move that 322 over. And now we've got X being greater than or equal to 78. So how do we answer this question? Well, we answer this question by saying we need to score a 78 or higher on the last exam. So we need to make sure we get a 78 or higher. As long as we got a 78 or higher, then we would get a B in the class. So we rewrote it up. We used our average. We worked through that one. We talked about what the average was. And then we rewrote it in terms of words so we could understand it better. Let's try another question or two. The next one we're going to look at is we're going to be comparing cell phone plans. So question 78, 77. We'll do 77, and then we'll do 78. And 77 and 78 are going to be very, very similar to that question 8 in your homework. And then the others we've covered as well. So there's an average question. We've kind of looked at on question 10. And this one's going to go with question 8. So question 77. This is on page, again, 114. We're going to be comparing different cell phone plans. So we're going to be trying to compare which cell phone plan is better for us. Most of the time today, cell phone plans have unlimited talk and text, but not that long ago, you were charged a flat fee plus so much per minute if you went over. So question 77. Latrice is signing up for cell service. She's got to decide between plan A, which is $54.99 a month, in this case with a free phone, and plan B, which is $49 a month, but requires her to buy the phone. Under either plan of service, she does not expect to go over the included number of minutes. After how many months would plan B be the better deal? So we want plan B to be the better deal. Now, what does it mean if I say plan B is the better deal? That is saying that it's cheaper. So we want plan B to be the better deal, meaning it's cheaper. So that means plan A is going to cost more than plan B. Because remember, how inequalities work is they always point towards the smaller number. And we want plan B to be the better deal, so plan B is going to be cheaper. So it's going to point towards plan B, open towards plan A. You could do this with cell phone minutes if you need to, or text messages. In this case, it's talking about the phone cost. Now, what we have is we're going to have a number of months, X, and we've got a fixed price per month that doesn't change, and we have to buy a phone or not buy a phone. Now, plan A. Plan A does not have a phone. The phone's included, so we don't have to pay for the phone. So we're going to let X be the number of months. So for plan A costs $54.99 times X, because it's $54.99 a month, and X is going to be the number of months, right? So if I ran this for 8 months, you would take your $54.99 times it by 8. That'd be how much you paid in that service. So this is a fixed amount here per month. Never changes. It's always the same. X is the number of months. Now, what about plan B? Okay, plan B is a little bit cheaper. Plan B is $49.99 per month. So that's $49.99X. But then we also have to buy this phone, which is $129. So this is going to be our inequality. At a certain point, you're going to be better off buying that phone rather than having it tacked onto your bill every month. And we need to know how many months we would need to use this phone to make it worthwhile. So we can go ahead and solve this. So we're going to subtract that $49.99X from each side. Now we've got that $54.99 minus that $49.99. It gives us a difference of 5x. And that's going to be greater than 129 here. We're going to go ahead and finish this out by dividing by the 5. And that gives you now x is going to be greater than 129 over 5. Now, what's 129 over 5? Just so we know. 129 over 5 is going to come out to be what? That comes out to be 25.8, right? And 25.8, we're going to have to go up to the next month. So we would go up to 26 months. So how many months do we need to keep the phone for it to be a better deal? Well, we need to keep the phone for at least 26 months. So as long as we can keep this phone for at least 26 months, then we're better off just buying it. But if we change phones out a lot, then we might be better off with the other plan, because the other plan might give you a different phone more often. So to make that plan work, and to make it a better deal for us to just buy the phone outright, we need to make sure that we keep that phone for at least 26 months. If we're not going to keep that phone for 26 months and we trade it in sooner, then that's not going to be the better deal for us. We want the other plan. One more, and then we'll take a short break. Question 78. Okay, question 78 here. We're comparing different rental moving truck rates. And some moving trucks may be cheaper, but charge you more per mile. Other trucks might be more expensive, but it's cheaper per mile. So we need to know how far we're going to go and figure out which truck's the better buy. So newlyweds, Bryce and Lauren, need to move their belongings to their new apartment. They can rent a U-Haul for $29.95 per day, plus 28 cents a mile, or a budget truck for $34.95 per day and 25 cents a mile. After how many miles, they want it to the nearest mile, would the budget truck be a better deal? So we want the budget truck to be a better deal. That means it's cheaper. So that budget truck is going to be the better deal, and it's got to be cheaper then. And so this is question 78 on, again, page 114. So what does that mean if it's the better deal? It means it's cheaper. So the U-Haul truck is going to be more expensive. Okay, so the U-Haul truck is going to be more expensive. So it's going to open towards the U-Haul or point towards the budget truck. Okay, so what do we know about each of these? Well, for the U-Haul truck, we're only going to rent this for 1 day. So the U-Haul truck is $29.95 a day. And then 28 cents a mile. So that's 0.28 times X, because X is going to represent the number of miles. And the more miles we drive in that U-Haul, of course, the higher the bill is going to be. So we have $29.95, that's just the cost to rent the truck, and 28 cents every mile. Now, what about the budget truck? Well, it costs more to rent at $34.95, but it's cheaper per mile at only 25 cents a mile. So that's 0.25 x there. So is everyone okay with how we have this set up? Solve it, and let's see how many miles we would need to drive for the budget truck to be cheaper. Move things around. So I'm going to move over that 0.25x with subtraction. And I'm going to move that $29.95 over as well. Okay, so working this out, we've got, looks like 0.03x. We've got 0.28 minus 0.25. Yep, that's going to be a 0.03x there. Inequality symbol stays the same. Those can cancel. We've got $34.95 and $29.95. That should be a difference of 5. That's going to be a difference of 5 there, and those can cancel. Divide by your 0.03. Inequality symbol stays the same. And 5 divided by 0.03. Well, that comes out to be 166.66, goes on forever. And we want it to the nearest mile. So that means we must drive at least 167 miles to make the budget truck cheaper. So if we're not going to drive that many miles, if we're only driving about 30 miles, then it would be cheaper to use the U-Haul. But if we're going at least 167 miles, then we would want to get the budget truck. So let's now go ahead and take a short break. And we will meet back here at, how about 10:35? So meet back here at 10:35. And then we'll cover the next section.